Hello, thank you once again and welcome to my channel. In this tutorial, we are going to continue with our project. In the previous section, we used Terraform to deploy a single VM in AWS. And we were able to launch our website. But the problem we have or we could have in such situation is if our website goes down or if the server itself goes down, our website will stop working. So for this reason, we are going to utilize some different AWS features, which we could use to provision our server so that if one server goes down, another one would launch automatically. For this, we are going to utilize the feature called auto scaling group. Auto scaling group allows you to launch as many servers as you want. You can scale them down as you want. If you want, as you can see in this very documentation by AWS, you would find, when you read it, you are going to see how it works. So for instance, in the example they showed here, they have the minimum of 4 servers. So in this case, they want 4 servers to be running. Then they have desired capacity of 6, maximum of how many? Maximum of 12 in total. So what happens in this case is that in the beginning, 4 servers are going to be running. So if one goes down or if the capacity increases more than described in the setup, so another more servers will be launched. So we are going to mimic the same thing in our code, although we are not going to launch as much servers. Also, the first thing I'm going to do is to first of all use T2, which is cheaper. And, um, and then we are going to make a couple of changes in our code. Because when you want to use auto-scaling groups, so some things are going to be, we are going to change some things. First of all, we are going to also use another feature called the AWS launch template. In my interpretation of this launch template, it's more like a class. If you're like in programming language, for example, you could create a class which is a blueprint of what you are trying to program. Then from that class, you then create objects. But I must say that this is in my own interpretation. So that's not how, but that's the easiest way to look at it. So let's proceed. First of all, we are going to make some changes here, like I said. The changes we are going to make here, let me maybe instead of deleting, let me just, no, yeah, let me comment this out. So instead of AWS instance, we are going to use AWS template, launch template. That's the change we needed to make. Another change we are going to make is we are going to change instead of AMI, the name now is going to be image ID. So I'm going to also comment this section out. And as you can see, we are getting an error here, right? So the name now should be image ID. We change the name to image ID. The next thing that we need to change, this is no longer required because this will be distributed along different zones. And we are going to comment out our security group here. We are going to define it again later. The next thing we need to define, just think about this. If we launch our servers or if we will launch our server or our servers, and if it goes down, what we need is for another server to be launched before that one goes down. Because if our server goes down before another one starts to launch automatically, our our website will go down, right? So in order to avoid that, we are going to use life cycle. That's what it's called. Create before destroy. By default, it says false, but we are going to use true. So what this is going to do is before any server goes down, another one will be launched. So this feature is really very useful. After that, we are going to create our interface. The interface is a network interface. Now we are going to associate our public IP address. Associate public IP. So this is going to associate the public IP to the interface. The next thing that we need here is now to call our security group. So as you can see, this is the same as what we commented out here. The difference is that now we call this security group. Another thing we need to do, because we launched our website inside of this script, but this is going to change. The reason is that when we are using the um, feature that we are about to use now, which is the auto scaling group, usually the servers need to be, or the VMs need to be established or deployed before our website is configured, which is not the case here because everything happens at the same time. So for that reason, we need to comment out or delete this section. We are going to delete it and declare it in a different way. The way we can declare this now is that we are going to use our user data, base code, base 64 in code, file, just let me type this out. I think we've got this more than we needed. We can use here path, mode, geo. What we are doing here now is to call our script. What we did here now, instead of using provisioner here, we are now using user data. So inside of it, we are calling our script, which we already have somewhere there. There is still an error. I think that should be fine. Something is still missing. Yeah, that's it. The next thing we need to do, let me just move this tag below. Doesn't make any difference anyway, but I just want it to be right below. The next thing we need to do is to define the VPC where we want our our deployment to run. To do that, we are going to use data AWS VPC, and I'm going to give it a name, my VPC. And because we are using the default VPC, true. This code should be outside. This code should be outside of our launch template. The next thing we need to do is to get also a subnet and link it up with the VPC. To do that, we are going to also use data. Let's call it AWS subnet, AWS subnets, and the name, let's call it my subnet. VPC ID. What we are going to do now is to link them together. Values, data, AWS my VPC .id. So we are fetching our VPC, hooking up with our subnet. Now we are going to declare our auto-scaling group. We are going to use resource AWS auto-scaling group, and the name we can call it a scaling group. Now we are going to define the amount of servers that we want to run. Let's say minimum size, let's have 2, and maximum size, we could have 5 or any amount that you want. Now we are going to tie everything together. VPC zone identifier, we are going to call data AWS, our subnet, AWS subnets .id, .ids. Now we have declared our auto-scaling group. Now we are going to make use of our launch template. Like I said earlier, this AWS template, launch template is more like like a class. So what we are going to do now is basically this is where you declare the features or all the things that you want your servers to contain. Now the next thing we need to do is to use our AWS launch template. Like I said earlier, launch template is like a class, right? So now we are going to use our launch template here. ID AWS launch template .id. Remember this name here, web server, is what we've got here in our launch template. We have declared a launch template here. The next thing we need to do is to call the version that we want to use. latest. This ensures that our server always is always declared or deployed using the latest image. Let's just add some tags. I'll just write anything there. Value, we can say EC2 EC2 instances. We can say propagate at launch through. So basically what this is going to do is going to make sure that this tag applies to all the EC2, all the VMs that we launch, and not only the auto-scaling group itself. That's just all it does. Now that our code is ready, let me go to my AWS console, and let's see what we've got. As you can see, this is the auto-scaling groups, which is empty now. We haven't got anything. Then let's go to instances and see what we've got. Instances, everything is terminated. Now let's go and run our code. Let's initialize it. Validate. Plan. Let's see if we've got any error. Something is wrong somewhere. Line 50, let's see. Let me change this. VPC ID. Or let's just plan it. Apply. Our resources are deployed. As we can see, we've got 4 resources. Now let's go back and check our code. Or rather, let's go back to the AWS and see what we've got. Now, we haven't got anything here, or rather, the servers we've got here are all terminated. Now let's go to auto-scaling group and see if we've got anything there. Yes. So that's our auto-scaling group. As you can see, let's click on it. Let me make some room. Here you can find all the details about the auto-scaling groups. As you can see, from here we can manage our instances. Look at the 2 instances that are deployed for us, as you can see. Now let's go to instances and see what we've got. Now you see 2 instances are running at the same time because we declared, if you remember, that we want 2 instances to be running at any given time, minimum 2. Now, let's see what's going to happen. First of all, let me check one of the instances. Let's check the other one. Let's try or test our website and see if it's propagated. Yeah, that's our website. A beautiful website. So the idea is that if this one goes down, we could check the other one. Let's try another, this IP. You see, the two IPs, we have two servers running at the same time. Now, let us try something. Let's try and delete one of these. As you can see, just take note of these two servers, 13 and 54. Let me pick one of them. Let me terminate it. Oh, first of all, remember, we've got the one I'm trying to terminate now is 54, 954. Terminate. It's shutting down. Let's refresh and see what happens. It's still shutting down. Let me keep refreshing. Let's see what's going to happen. It's terminated. Let's see let's see. We still have two servers here. Let's try and delete one. Anyway, because obviously the charges are running. So we are going to, as you can see, we still have one server here running. 913 is running. When we go there and check again, 913 is there, and then we have this one. What I was hoping was for the two of them to be showing here, which is what typically happens. But you understand the gist, or you understand how it works. So with auto-scaling group, we can provision our servers as many times as we want. Let me just try something quickly. Go back there. That's the life cycle that we declared. Okay. Another one just started initializing. As you can see at the top, that one is 76A. Now let's go back there and see what we've got. As you can see, 76A. So we've got our two servers running. So that's it. Now, another thing that we are going to check is this. As you can see, to test our websites using the two of the servers, we have to use individual IP address of each server. As you can see, this very server 913 has this IP. In order to access the website, we use this IP. To access the website of the new running server, we have to use a different IP, which is not ideal. We should do something so that we can have a single IP that we can use to connect to all the server. We can link the two servers to a single IP. So to do that, we are going to use a load balancer. So in the future video, we are going to see how we can use a load balancer to balance the two servers, or no matter whichever amount of servers we are going to run, so that we can use only one IP address to access it. So that's it for this tutorial. Thank you for watching and see you next time.